Dear students, today we'll see what do we mean by silicon controlled rectifier, SCR. Okay. Now SCR is a device which can come under power electronic devices, or you can also study it under semiconductor or devices. But mainly it is a power electronic device. Okay. Now SCR is made up of 4 semiconductor layers. Okay, and the layers are, if you draw the layer diagram, the layers will be, you will be having a first P layer, then you will be having a N layer, then again a P layer, and then a N layer. So this will be the 4 layers which can constitute a silicon controlled rectifier. Now this we will name it as P1, N1, P2, N2, right? And the P type of material, here you can take one terminal. That terminal will be called as anode. And at N, last N type, you can take one terminal, and that can be called as cathode. Okay, and here you can take one terminal, and that can be called as gate. Okay, so it is a 4-layer 3-terminal device. Now if I have 4 layers, then this will be the first PN junction, junction 1. This will be the second PN junction, junction 2. This will be the third PN junction, junction 3. Okay. So if you want to define what is SCR, then you can define SCR as a 4-layer device. 4-layer device, 3-terminal device. The 3 terminals are anode, cathode and gate. And it is having 3 junctions. First junction is here, which is J1. Second junction is here, which is J2. Third junction is here, which is J3. Okay. Now, this is the construction of an SCR, silicon controlled rectifier. Okay. Now, it is made up of silicon and it is controlled rectification. Okay. Controlled rectification means output voltage you can vary. Okay. Whereas uncontrolled rectification you can get by simple diodes also. Simple diodes can give you uncontrolled rectification. Rectification means AC to DC. Okay. But here you are getting controlled rectification. Means the output voltage, whatever you are going to get, input will be AC, output whatever or DC you are going to get, that will be varied, that can be varied in terms of voltage. So output can be varied in terms of voltage. So it is controlled rectification. So it is called as silicon controlled rectifier. Okay. Now, this SCR can be in 2 states. One is called as forward bias, and the other one is called as reverse bias. Okay. Now, forward bias and reverse bias are the 2 states in which you can operate the SCR. Now, mainly for any application, it is operated in the forward bias condition only. That is in the first quadrant only. Okay. Now, how does it operate? For its operation in forward bias, for almost all applications, it is being used in forward bias. So, for its application in forward bias, anode has to be connected to a positive terminal, and cathode has to be connected to a negative terminal of a battery. So this is the battery, plus minus, this is voltage, okay, between anode and cathode, whatever you are going to give. So positive, anode should be positive with respect to cathode, then you are in a forward bias condition. Okay. Now in this condition, what will happen? Because this is positive and it is connected to P type of material, and this is negative, it is connected to N type material. The first junction J1 will be forward biased. Similarly, if you see this polarity of this voltage for junction J2, N is connected to positive and P is connected to negative. So junction J2 will be reverse biased. Similarly, if you see junction J3, P will be connected to positive, N will be connected to negative. So junction G3 will be forward biased. Okay. So if you apply a voltage like this between anode and cathode, where anode is made positive with respect to cathode, then in that case, junction J1 will be forward biased, junction J2 will be reverse biased, junction J3 will be forward biased. Now J1 and J3 are forward biased, so no problem, current can flow. Current can flow. Current can flow. But the second junction has to support your flow of current. Has to support the flow of current through the SCR. Then only we can say SCR is on. We see that junction J1 is forward biased, junction J2 is reverse biased, and junction J3 is forward biased. Now as far as the anode current is concerned, which is going to flow through the SCR, for that the first junction forward bias is not a problem. It is allowing the current to flow. The third junction forward bias is not a problem. It is allowing the current to flow. The second junction is reverse bias. The second junction is a reverse bias. Okay. Now this second junction has to go into breakdown. It has to, as we have studied avalanche breakdown, Zener breakdown. So avalanche type of breakdown, it has to go into a breakdown. And for that to go into breakdown, you have to increase this applied voltage. This applied voltage has to be increased. Okay. Now, if you increase the applied voltage over here, then this junction will go into breakdown. And once this junction, second junction J2 goes into breakdown, the anode current starts flowing and we can say the SCR is in on condition. SCR is in on condition. Okay. But practically, the voltage required here to make the second junction reverse bias will be very high, and it will not be suitable for many applications of SCR. Okay. So for that purpose, the third terminal will come into picture. The third terminal is called as gate and it is called as a control terminal. Okay. So this third terminal, whatever we are having, if we give a positive pulse at the third terminal, plus minus, you give a positive pulse. Okay. Now this positive pulse, if you give, even if the anode cathode voltage is in a minimum range, if this positive pulse is given at the gate, it will make the second junction to break down early. It will make the second junction to go into breakdown, and by this positive pulse here, application of this positive pulse here can make the current to flow, can make the SCR on, can make the SCR to conduct. Okay. So this is the way. Either you can make it on by increasing the anode cathode voltage and making the second junction go into breakdown. So in that case, the anode cathode voltage will be very high. But if you want for a practical purpose, then you can keep this anode cathode voltage little less, and at the same time you can apply a positive pulse at the gate. So this positive pulse at the gate will make the second junction go into breakdown early for a minimal anode cathode voltage. Okay. So that is the best way to use SCR for practical purpose. Okay. Now this is what happens in forward bias, and this is what is used in almost all the applications of SCR. So it is used in forward bias. When it is in reverse bias, the anode is made negative and cathode is made positive. And in that case, junction J1 and J3 will be reverse bias and J2 will be forward bias. Now in that case, there will be no current flowing through the SCR. It will be in a block stage. It will be reverse blocking stage. Okay. Now this is what introduction of SCR will tell you. Now once you go to see the VI characteristics of SCR, then you can understand how does the SCR operate in forward blocking state, forward conducting state, and reverse blocking state, and afterwards reverse breakdown.